Tomorrow you're going to be given a little formula guide that'll have these things on there. I'll also leave this up there because this, even though that's the tool, that's the ratio between all the sides. It's not quite clear to everybody what that means. These formulas are a way to find what you're looking for over here. So you may want to write down on some of these which one's long leg, short leg, hypotenuse, things like that. All right, number one, when we're trying to decide whether it's an acute, obtuse, or right triangle, the first thing that has to happen is we have to make sure that it is a triangle. So you need to test the numbers out and make sure, that it's going to actually form a triangle. But then, once you know it will, that's a different test than testing whether it's acute, right, or obtuse. When you're talking about whether it's a triangle or not, the two smallest sides have to add up to more than the biggest side. Okay? But when you're testing whether it's a right triangle, I think it's easier if you will start by talking about the hypotenuse, C. Okay? Because even though the Pythagorean theorem has a squared plus b squared equals c squared, we can reverse that and say c squared is equal to a squared plus b squared. And to me, it's easier to understand whether it's an acute or obtuse if we start by talking about the hypotenuse. If c squared is equal to a squared plus b squared, that makes it a right angle. But if c gets smaller, if what used to be the hypotenuse gets smaller, that is going to shrink that 90-degree angle. Does that make sense? There's A, B, and C when it's a right angle. But if you make C smaller, then this is going to be acute. If you make C bigger, that's going to be obtuse. So when you're looking to decide whether it's acute, let's say c squared, if that is less than a squared plus b squared, then that makes it acute. If it's greater than, that makes it obtuse. We've got the hypotenuse is unknown. So we plug what we do know in for A and B and help us find C, or the hypotenuse, which they call an unknown value of x. All right, so here we go. We throw them in the Pythagorean theorem. 28 squared plus 45 squared should be equal to c squared, or in this case, x squared. So then you go to your calculator. Then 28 squared plus 45 squared. What do you get? No, you don't. What's 28 squared plus 45 squared? 2,890. 9. That's equal to x squared. So then you have to take the square root of that. When you're doing the Pythagorean theorem, your last step is going to be you're going to need to take the square root to find c, or x. And that would give us what? 53. That's this length right here. That's how far it is from that point to that point. And that number has to make sense. It has to look logical when you're looking at the triangle. Okay? That was the left foot. Let's look at number 3. Now in this case, we know the hypotenuse. We're missing a leg. So even though we start out with the Pythagorean theorem, we're going to have to subtract to get whatever we're going to call that A or B by itself. So if we set it up and call this A, B, and C, and then we put the Pythagorean theorem to it, 56 squared plus x squared equals 106 squared. In order to solve for x, you're going to have to subtract whatever you get. Let's go ahead and multiply it out. 56 squared is what? We'll do it the long way for a little while. Say it louder. That's not 50. Is that 56 squared?
Oh, 31, 36, yes.
And 106 squared is? Then we have to subtract that amount from both sides. We've got to get x squared by itself. So we're going to subtract 3136 from 11,236. This is just solving for x. This is old algebra 1 stuff. How much? So that should be the value of x squared. Now we have to take the square root, again, of both sides. We get 90. Okay? And that needs to make sense to the problem. This is our hypotenuse. 106 should be the longest side. So you don't need to put a value of 8100 here. You forgot to take the square root, if you do. Now, let me show you what a quick way is that we can do this. If we know, let's start out with a squared plus b squared equals c squared. If we are missing one of the leg values, like this, let's say we called that b. Then, when we're looking for b, we know that b squared is going to be c squared minus a squared. And we know we're going to have to take the square root of both sides. So that leg is going to be equal to what we get when we subtract and what we get when we take the square root of that. So if you know ahead what you're going to do, you might be able to do it all at one step. The better you come with math, and the better you are with math, and the better you are with numbers, the more efficient you can be in life. So maybe you won't use this exactly, but you don't want to be counting on your fingers, okay, when you're 30 years old, trying to count up change and not even knowing whether they're giving you the right change at McDonald's or not, okay? So we hopefully will become more efficient. So then if we apply that to number 3, if we want to find x, then we're simply going to take the square root of the square of the hypotenuse minus the square of the other leg. And we need to make sure we put that whole thing in one big set of parentheses when we do it. So go ahead and practice in your calculator. Type that in. See if you get what we thought 90 as the length. Square root, and then in parentheses, hypotenuse squared minus other leg squared. All right, we're going to do 7 and 8 first, And then we're going to come back to 4, 5, and 6. So if we're going to figure out whether it's a Pythagorean triple, then the numbers have to fit into the Pythagorean theorem perfectly. So if you're looking at number 7, 30 is the only one that could be our hypotenuse. Okay? So 30 squared, which is our hypotenuse squared, should be equal to the other two guys, the sum of the other two legs squared. Now, if those two things are equal, then it satisfies the Pythagorean theorem, which makes it a Pythagorean triple. So plug in 30 squared, get a number. Then plug in 18 squared plus 24 squared, get a number. If those two numbers are the same, then it is a Pythagorean triple. 30 squared is 900. 18 squared and 24 squared is also 900. So yes, this is a Pythagorean triple. Get to number 8. 11 is our potential hypotenuse. So 11 squared should be equal to 5 squared plus 8 squared if it's a Pythagorean, if it's a right triangle, sorry. If it's a right triangle. 11 squared is 121. What is 5 squared and 8 squared? 25 and 64, 89. So they're not equal. So no, this is not a right triangle. Now, when we take a problem like this and we go up here, not only do we find out whether it's a right triangle or not, but we also need to know, well, if it's not a right triangle, is it acute or is it obtuse? Because it's got to be one or the other. It's either acute, right, or obtuse. Well, this one's not a right. What is it? So if we apply the rules that we learned on number 1, this is our hypotenuse. This ended up being greater than the sum of the squares of the legs. Makes it obtuse. We weren't asked to do that on number 8. All we were asked to do was figure out whether it's a right triangle or not. But on number 4, 5, and 6, we are. We have to determine whether it's a right triangle or not, and if it's not, decide what type it is. So we set it up the same way. 8 squared, is that equal to 12 squared plus 14 squared? Is it? Someone said they are the same. Are they the same? They're saying they're the same. What is 18 squared? Twelve squared is 144. 14 squared is when you add these two together, $340. If the hypotenuse is too small, which in case it is, the hypotenuse is smaller than the sum of the other squares of the legs. Sum of the squares of the other legs, sorry. If it's too small to be a right triangle, then it must be acute. Here, the 50 is the bigger one, so that's going to be our C. Is 50 squared equal to 14 squared plus 48 squared? 2500. That's 196. What's 48 squared? When you add those two up, you do get exactly 2500. So yes, this is a right triangle. Don't put yes or no on these because there's three choices.
Yes.
First one was acute. What about number 6? No. No. Neither. No. No.
It's not a triangle.
It's not a triangle.
How?
Well, we learned that on the last test. Because 16 plus 24 is 40. And that won't reach to 42. The sum of the two legs has to be greater, or the sum of the two smallest sides has to be greater than the length of the biggest side. So that one would not make a triangle at all. Not possible. Triangle. Number 8, however, would. This one is not a right triangle, but 11 squared, which is 121, is greater than 25 plus 64. So since it's greater than, this one would be obtuse if it asked. Number 9, we want to figure out how far, it says the length of EG. That means how far it is from E to G. We're told it's a rectangle. That means we know we have right angles everywhere, which means I have a right triangle right here, and EG is my hypotenuse to this blue right triangle. So I have 9 squared plus 12 squared should be equal to GE, or EG. So the shortcut, EG squared. The shortcut is to take the square root of 9 squared plus 12 squared, and that would be the number I want. Funny cheap. What'd you get? 15? 18.
I got 15.
Did around the entire 25 plus 81 equals 225. Okay, we get it. Right. I don't know. I got 15.
15. This is not a 30-60 special or a 45-40 special. This is just a Coach Nipton special. This is a 3-4-5 triangle. Everything's in a ratio of 3 to 4 to 5. 9 is 3 times 3, 12 is 4 times 3, and 15 is 5 times 3. Everything is in a ratio of 3, 4, 5. Number 10. We need to know how far Mountain Highway is before we can figure out how much farther it is to go that way. This is leg, this is hypotenuse. So I need to figure out the leg, so 25 squared plus, we'll call it B, A, C. So then I subtract and take the square root. I'm going to be subtracting and taking the square root. And I'm going to just put all that in at one time so I can find that length. How far is that? What should we put this in the calculator? 60? So if that's 60, then that's a total of 85 miles to go this way. Total of 65 miles to go this way. So it's 20. That question is, how many miles could she save? 20 miles. That's how much she would save. 20 miles is how much she would save. Make sure you answer the question. (11) asks how far it is from L to M. What'd you get? Who did it? What'd you get? ML. Might get anything different. Okay. So how'd you do it? Did you find this piece first? Okay. Tell me something. Why couldn't I do this? This is wrong, by the way. But why? 35 squared plus 100 squared should be LM squared. Why not? I don't know what the measure of this angle is. If I knew that, and it kind of looks like a right angle, and so it's kind of tricky, but we're not told it is, so we can't do it that way. So we have to do the long way. We have to find each piece. This is going to be a leg. That's the hypotenuse. When I focus in on just this little triangle there. So 28 squared plus b squared is equal to 35 squared. So b squared is 35 squared minus 28 squared. I'm going fast because we've been doing this over and over. So b is the square root of 35 squared minus 28 squared. Throw that in the calculator. What do I get? 21. Okay. So this distance is 21. Now I go over here to this right triangle. I have a hypotenuse of 100 plus, call this one b. So b squared is 100 squared minus 28 squared. And so b is the square root of 100 squared minus 28 squared, which is 96. So Ln is 21, Mn is 96, Ml is, what do we say? 17 when you add them up. Distance from the ship to the dock. Okay, so if we use a map and we go 6 miles north and then 4 miles east, how far are they from the dock? We would need to have 6 squared, 4 squared, so we would need to use A and B. That's our legs. This one also says A and B. Those are our legs. And so far A and D are both possible. Solve for C. This says add A, B, and C together. That's not what I want to do. That would give me the perimeter of this triangle. I just want to find C. Here's the dot. Here's me. For the ship, if I'm on the ship. So the straight line distance is plain old C. So D should have been the correct answer on that one. All right, 13. Now we're into a special triangles. Now we break out the little formula chart. We look up at the board, say, okay, so 45, 45, 90. So that means this is leg, hypotenuse. Hypotenuse is opposite the right angle, and I'm looking for the hypotenuse, and I know a leg. So hypotenuse, when I know a leg, because the hypotenuse will be the length of a leg times the square root of 2. So 10 square root of 2. Done. Leave it like that. Just fine. Number 14, I've got hypotenuse, leg, leg. Now if I find one, I've got the other, so I don't care. But I've got the hypotenuse, and I need a leg. So I'm going to use this one. Leg is equal to the hypotenuse divided by the square root of 2. Equal to hypotenuse, length, which is 13 square root of 2, divided by square root of 2. Those cancel, so my leg is plain old 13. And so if that leg is 13, so is that. C is 13, so is B. Now we have a 30-60-90. I have short leg, I don't know long leg, and I don't know the hypotenuse. So if I know the short leg, all I have to do is double it to find the hypotenuse. Okay? So if the short leg is 7, that hypotenuse is 14. And then if I want the long leg, all I have to do is take the length of the short leg times the square root of 3. So long leg equals length of the short leg times the square root of 3. And I'm done. Another 30, 60, 90. This time I know the hypotenuse, and I want to find long leg and short leg. I know the hypotenuse, then I take half of that to find the short leg. So that's the ratio between the hypotenuse and the short leg. One is twice the other. This is the hypotenuse, that means the short leg is 6. And then if I want to find the long leg, all I have to do is take that short leg length and throw a square root of 3 on it. Number 17. Here we have the hypotenuse, and I need to know the legs. This is a 45, 45, 90. So if I find one, it'll be the same as the other. I don't have to use a bunch of formulas. A leg is equal to the hypotenuse divided by square root of 2. Hypotenuse is 12, so m will be 12 over square root of 2. You put that in the calculator, you get a value. If you rationalize it, you get another value. If you multiply that by square root of 2 over square root of 2, square root of 2's become plain old 2. And then we get 12 square root of 2 on top. Now don't forget to reduce that. The 12 and the 2 become 6 and 1. So really this is just plain old 6 square root of 2. What's that in decimal form? 8.5. If she rounded right, I'm guessing she did. 18. I don't know the hypotenuse. I don't know short leg, but I do know long leg. Square root of 15. Uh-oh. Half of you just skipped this problem. So they had a square root of 15. We hadn't seen that in a while. So, but the rest of you are going to follow the rules because it can't be that bad, right? Short leg is equal to the long leg divided by square root of 3. All right? So the short leg is equal to the long leg divided by square root of 3. Now, those of you that remember your radical rules, remember that If you have division of two separate radicals, you can put them under the same, which makes it square root of 5, which is 8.7? That doesn't sound right. Making sure we rounded right. I heard a 2.26, so I was wondering if we rounded right. So then that's short leg. So then the hypotenuse is either 4.4 or double square root of 5, which is just 2 square root of 5. You got square root of 5, 2 square root of 5, and square root of 15. Now that was a little bit funny. Yeah, that's right. Kite string is 50 feet long. The string makes a 45-degree angle to the ground. How high above the ground is the kite? That's an altitude. How far is that? Well, that means this is hypotenuse, and this is leg. If I want to find the length of a leg, I take the length of the hypotenuse and divide it by the square root of 2. Leg equals length of the hypotenuse divided by square root of 2. So 50 divided by the square root of 2, I'm not going to rationalize it this time. Well, I can do it in my head now, I've done it enough, but I think it's 25 root 2, which is what? What's 25 root 2? What's 50 over square root of 2? Same thing. 35.4? So we're approximately 35.4 feet off the ground. Oh, here it is. 25 root 2. You're 50 feet from the screen at the drive-in. Your eye is on a horizontal line with the bottom of the screen, and the angle of elevation to the top of the screen is 60 degrees. How tall is the screen? Okay? This is short leg. We need hypotenuse, because we're asked, is that right? Nope, we're asked for how tall is the screen. My bad. We're asked for long leg when we know short leg. Short leg is 50. This is a 30, 60, 90. Short leg is 50. Long leg is going to be 50 squared to 3. D. Draw a diagram. Angle S is 60, so I'm going to try to make it somewhat right. 60, there's S. Angle A is 90. I didn't make it right. Strike it. A, 90. A little higher. About that. S is 60. AT, this is T. AT is 8. What is the length of SA? What is the length of ST? What is the perimeter? So this is going to be a 30, 60, 90. This is my short leg. This is my long leg. This is the hypotenuse. So if I want short leg, I take the long leg divided by the square root of 3. So short leg is going to be 8 over square root of 3. Or rationalized, you would get 8 root 3 over 3. Or as a decimal, what would you get? Sounds about right. And then length of ST would just be, ST is the hypotenuse, it's going to be twice the short leg. So probably around 9.2 is what I'm guessing, unless we rounded wrong. So the perimeter, 8 plus 4.6 plus 9.2. How much? 8? 22 locations or vertices of a right triangle. You want to fly from city A to city B. How many miles would you save if you flew directly from city A to city B instead of through city C? This is a 60, we got a 30, this is the hypotenuse, this is short, this is long. We need to find short and long. So if the hypotenuse is 600, short is half that, and long is that times square root of 3. 300 square root of 3 is what in decimal form? That doesn't sound right. How much is 300 square root of 3? 519.6. So when you add that together, I get 819.6 if I go this way. If I go the short way, I save 219.6. 25-foot ladder is leaning against a building. Here's the building. Here's the ladder. We're going to assume, here's the ground. We're going to assume the building is straight with the ground. We're going to, the ladder makes a 60-degree angle with the ground. So here's our 60 down here. That means this has got to be 30. How far is the ladder from the base of the building? We want this distance. We're told it is a 25-foot ladder, which is going to be the hypotenuse. And we need to find short leg. Hypotenuse and short leg on a 30, 60, 90. 1 to 2. So the hypotenuse is twice that. That means we are 12.5 feet from the building. I know the little apostrophe means feet, right? So if we want to list the sides of an angle, of the triangle, from smallest to largest, your sides, you need 2 letters. Okay? Let's make sure we don't get confused and we know how to write a side and an angle. Sides, you need 2 letters. The sides are line segments. The sides are we're already told how long they are. We just have to give their names. This is DF. This is FE. And this is DE. The angles, since I only have one angle at each corner, I don't have a bunch of intersecting lines, I can just call them by one letter, angle whatever. Well, if DF is the longest side, is the shortest side, then E, angle E, is the smallest angle. And if DE is the longest side, then angle F is the largest angle, which leaves me angle B in the middle. Over here, since I'm given the angles, I'm going to go ahead and write those first. Angle Z is the smallest. Angle Y is the biggest. And then 45 is in the middle, so that's angle X. Which means, if that's the smallest, if Z is the smallest, YX is the shortest, or XY is the shortest side. If angle Y is the biggest, and the side opposite that is ZX is the longest. Who did I leave out? Z. Is it possible to construct a triangle with the given lengths? Is 3 plus 4 greater than 5? Yes. So then it is a possible triangle. Is 4 plus 1 greater than 6? No. So that one's not a possible triangle. The measurements of all three interior angles of triangle PQR. Where is PQR? Oh, an isosceles triangle, PQR. The interior angle P measures 130. Isosceles, PQR. Okay. Oh. Okay. Is there an issue here? Okay. So angle P is 130 degrees. Oh, it's isosceles. I got you. Okay, so it's isosceles. Let me draw a little more isosceles. Any of those sides are the same. So if that's 130 degrees, I have 50 degrees left over. 25, 130, 25, and 25 gives me a total of 180. Find the value of X. This is an equilateral. So if this is 3x, so is this, and so is this. So 3x's better equal 180 degrees. So 9x better be 180. Divide by 9. I better get 20 as the value of x. Another way to do that, if it's an equilateral, this is 60. So if 3x equals 60, then x is still 20. Either way. This is 50 is an isosceles. I know it's isosceles because the base angles are the same. And if they're the same, so are the legs. So if the legs are the same, 35 is equal to 5x plus 5. Subtract 5. Divide by 5. X is 6. Here, again, I have an isosceles triangle. That means the base angles are the same. So if that's 72 degrees, so is that. So 9x has to be 72. That means x has to be 8. 32. Is this the last one? Okay. I've got three angles that have messy formulas for each. But I do know that they have to add up to 180 degrees. So the 8x plus 4, the 4x minus 8, and the 3x plus 4 have to add up to 180. Now let's clean this up. It's a messy room. That's 12, 15x. A 4, a minus 8, and a plus 4. That's a 0. Equals 180. Divided by 15. X would be how much? I did finish. Oh, what about these?
Those are
Oh. Oh, we gotta do these real quick. Bell's gonna ring real quick. This is a median. This is an angle bisector. No, it's not. That's a median. This is a perpendicular bisector. This is an angle bisector. This is an altitude.